Hey everyone, welcome back to my channel. As the title is telling you, today we are going to solve a quadratic equation by all the three methods: factorization, completing the square, and quadratic formula. This is a great way to understand how each method works and when to use them. So let's get right into it. So our equation is 4x squared minus 12x plus 5 equals 0. On this slide, I am going to use the factorization method. Now, if I compare this given equation with the standard form of the quadratic equation ax squared plus bx plus c equals 0, the value of a is 4, b is minus 12, and c is 5. So, I am looking for two numbers which when added give me b. What is b? Minus 12. And the same set of numbers when multiply give me the product of AC. What is product of AC? 4 times 5, 20. Clearly, the numbers are minus 2 and minus 10 because minus 2 times minus 10 is 20 plus 20 and minus 2 added to minus 10 is minus 12. So, let's rewrite our equation. So, 4x square, this minus 12 is what? Minus 2 added to minus 10. So, minus 12x will be minus 2x added to minus 10x plus 5 as it is equals 0. Let's regroup our terms. So 4x square minus 2x in one of the brackets minus 10x minus 5 in one of the brackets. If you are wondering why I have changed the signs, because I have taken this minus outside. Whenever there is minus outside, all the inside signs get changed. Now we will take the common factor. So what is the common factor of 4x square minus 2x? It's 2x. 4x square divided by 2x is 2x minus 2x divided by 2x is 1 minus what is the common factor of these two terms? It's 5. 10x divided by 5 is 2x minus 5 divided by 5 is 1 equals 0. So this is my first term, this is my second term, and I can see that in the first and second term this 2x minus 1 bracket is common. So let's take out this bracket common or outside. From the first term, when I take out 2x minus 1 outside, what is left? It's 2x minus, from the second term when I take out 2x minus 1 outside, I'm left with minus 5 equals 0. Now, according to null factor law, whenever the product of two terms or two numbers is 0, then at least one of them must be equal to 0. So I get 2x minus 1 equals 0 or 2x minus 5 equals to 0. These are just our linear equations. So it will give me 2x is 1 and x as 1 half, which is one of the solutions of this quadratic equation. From here, I would get 2x as 5 and x as 5 over 2. So x as 1 half and x as 5 halves are the two solutions of this given quadratic equation. Okay, so now let's solve this quadratic equation by completing the square method. So the first step in completing the square method is to make the coefficient of x square as 1. In this case, it is 4. How will I make this as 1? By dividing all the terms on both sides of equal to sign by 4. 4 divided by 4 is 1. 1x square means x square minus 12 divided by 4 is 3x. 5 divided by 4 as it is and 0 divided by 4 is 0. My next step is x square minus 3x. Take this plus 5 over 4, the constant term, to right side, and of course the sign would be changed. So it will be minus 5 over 4. Now comes the most important step. I want to create or complete the square, the perfect square on left side. And to create that perfect square, I will be adding a number, and that number is coefficient of x divided by 2 whole square. What is the coefficient of x? It's minus 3. So minus 3 divided by 2 whole square. This is same as 3 over 2 whole square because minus square is positive. So I would be adding this number on left side as well as on right side. So let's do that. X square minus 3x plus 3 over 2 whole square equals minus 5 over 4 plus 3 over 2 whole square. Now, this left side is the perfect square of the binomial. Which binomial? It's the perfect square of this x minus this 3 over 2 whole square. Whenever you have minus over here, it's always minus. If it is plus, it would be plus. So I have written my left side of the equation as the perfect square of x minus 3 over 2. That's why this method is called completing the square method. Let's solve the right side. It's minus 5 over 4 plus 3 square is 9 and 2 square is 4. So it will give me x minus 3 over 2 whole square equals, the denominators are same, negative 5 added to 9 will be 4, so 4 over 4 and that gives me 1. To get rid of this square, let's take the square root on both the sides, so x minus 3 over 2 whole square equals square root of 1, and whenever we are taking a square root of a number, it always has two answers, so one in plus and one in negative, so we always write plus minus. Now this will cancel out this one. So x minus 3 over 2 is equal to plus minus square root of 1 is 1. This gives me two equations. X minus 3 over 2 is equal to plus 1, and the another equation will be x minus 3 2 is equal to minus 1. So there are two possible solutions. Now it will give me x is equal to 1 plus 3 over 2, and it's like 1, and to make it 2, I will multiply numerator and denominator with 2, so it's 2 over 2 plus 3 over 2, so x is equal to 5 over 2. So this is my one of the solutions. Let's solve this equation in the similar manner. So minus 1 plus 3 over 2, and to make it 2, multiply both by 2, numerator and denominator, it is minus 2 over 2 plus 3 over 2. So this is x. So x equals 3 minus 2 is 1, so 1 over 2. So x equals 5 over 2 or 5 halves, and x is equal to 1 half are the two solutions of this quadratic equation by completing the square method, and we got the same solutions when we did it by factorization. Let's do the last method using the quadratic formula method to solve this quadratic equation. So, compare it with the standard form of quadratic equation ax square plus bx plus c equals 0. My a value is 4, b value is negative 12, and c value is 5. So, we will find the quantity called discriminant denoted by delta, which is equal to b square minus 4ac. Now what is b? It's negative 12 square minus 4 times a. What is a? 4. And what is c? 5. Now negative 12 square is 144 minus 4 times 4 is 16. 16 times 5 is 80. So 144 minus 80, which gives me 64. Is this delta value, discriminant value, greater than 0? Yes. That means this linear equation has two real distinct roots. Distinct means different. And those two real distinct roots are given by the quadratic formula x equals minus b plus minus square root of discriminant delta divided by 2a. Let's put in the values. Minus, what is the value of b? It's minus 12. So minus 12 plus minus square root of delta is square root of 64 divided by 2 times, what is a? 4. It gives me minus minus plus, so 12 plus minus root of 64 is 8 divided by 2 times 4 is 8. So it will give me two values of x. So one will be 12 plus 8 divided by 2. 12 plus 8 is 12. Okay, so this is 8, my bad. Okay, 12 plus 8 is 20. 20 divided by 8. When simplified, it will give me 5 over 2. So my one solution is x equals 5 over 2. And for the another one, when I will take this minus 8, it will be 12 minus 8 divided by 8. 12 minus 8 is 4, and 4 divided by 8 or 4 over 8 gives me 1 half. So my next solution of x is half. So these are the two solutions of this quadratic equation. Now, if you have clearly seen, we are getting, of course, we are getting the same solution. Each approach is giving us the same answer, but of course, the steps are slightly different, and knowing them all gives you like options depending on the question or depending on your comfort level, which method you want to use in which kind of question. So thanks for watching. If this video has helped you, don't forget to like, subscribe and share it with someone or your friends who might find this video useful. And if you want such kind of more useful math content, just stick around. There is a lot more coming. Thank you for watching and I'll see you in the next one. Bye bye.